So today we're going to be looking at solving systems of equations using substitution. So one way that we've learned that we can solve this system is by graphing. So you could put both of these equations into Desmos and find the point of intersection, and that would be the solution. But using substitution is an algebraic method for solving systems. So this should look pretty familiar since you have one variable already isolated. You already know what x is. X in this example is equal to 1. So all you would do is you would substitute 1 in for x in your first equation and solve for y. So when you do that, our first equation, if we substitute 1 in for x, we would have negative 5 times 1 plus y is equal to negative 11. So that's our first equation rewritten, knowing what we know about the value of x in our second equation. And then from here we would simplify what we can. So negative 5 times 1 is negative 5 plus y is equal to negative 11. Then to solve for y, well, we want to solve for y, right? So what is happening to our y? Well, our y is being added to negative 5. So in order to undo that, right, we have to do the inverse operations. We want to well, in this case, we want to add 5 to both sides, so that way we create a 0 pair here. So if we add 5, negative 5 plus 5 is a 0 pair, but anything we do to one side of the equation, we have to do to the other side. So now we have y is equal to negative 11 plus 5, and remember your number line, right? If you have negative 11 on your number line here, and you're adding, that means you're going to the right 5, so we would end up at negative 6. So now we know that y is equal to negative 6. We know that x is equal to 1, so the solution to this ordered pair in a xy coordinate would be 1, negative 6, right? Because this was our x value, and this was our y value. Okay, so if you were to graph these two equations on Desmos graphing calculator, you would see that they intersect at the point 1, negative 6. And let's do one more example. So very, very similar here. We're given the value that x is equal to negative 5. So if we know that x is equal to negative 5, we're going to substitute negative 5 into our equation for x, into our first equation for x. So we're going to get 10 times negative 5 plus 7y is equal to negative 15. Simplify 10 times negative 5 is negative 50. Bring everything else down. Now we have our y is being multiplied by 7, and we're adding negative 50 to that value. So in order to undo that, I'm going to get rid of this minus 50 first. So I want to get rid of that, and since it's addition, we know that adding the opposite of any number will create a 0 pair. So negative 50 plus 50 creates a big 0 there, so it no longer has value. We're going to do that to the same side of the other side of the equation, sorry. So on the left-hand side of our equation, we still have, my marker's running out. 7y is equal to negative 15 plus 50. So your calculator. Negative 15 plus 50 is equal to 35. So now we have 7 times y is equal to 35. So you might just be able to know that, well, 7 times 5 is equal to 35, so y is equal to 5. Or you can know that y is being multiplied by 7, and in order to undo that, we want to create a 1 pair whenever we have multiplication. We want to divide both sides of our equation by 7. 7 over 7 will just be a 1, and 1 times anything doesn't add any value. So now we're left with just y is equal to, and 35 divided by 7 is 5. So y is equal to 5. So the solution to this equation would be x, which is negative 5, y, which is positive 5. So again, if you were to graph both of these equations into Desmos graphing calculator, you would see that they intersect at the point negative 5, 5.